Welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Today we're going to be looking at functions in Python, and it's the first week of the month, so it's going to be aimed at absolute beginners. And the advantage of streaming it live is that you can ask questions during the session. I will be watching the YouTube chat, and I'll also be watching our Slack channel in Learning to Code as part of the Beginners Python group on Slack. So there's instructions on joining Slack down below in the YouTube comments or in the meetup description. But if you haven't got that, just try YouTube. YouTube does censor a few things, but hopefully your questions will get through and I will try to answer them. So we're going to use Google Colab for today's session, and Google Colab means you don't have to install Python on your computer. It runs on a special computer that a virtual computer that Google gives you for free, and it's quite powerful, so it works really well. It's actually, some people only ever use Google Colab, they don't ever get around to installing Python on their computers, but it's a very good way of learning Python because it's interactive. You can type in a function and a command and get the result back straight away, and then continue step by step and really learning what's going on. So there's a link down below in the YouTube video or on the meetup page where I'm now. I'm going to click on the link. It's to this colab.research.google.com, and that will pull up the Colab notebook for you that I've set up previously, and you'll notice it says up here changes will not be saved. That's because you're looking at my version of it. So what I recommend is click on copy to drive, and that way you can make changes and save them, and you can always go back to the original link if you want to see what the original was. So I'm going to click on copy to drive and be viewing it in a different account. There it is. We've got private outputs, so the answers aren't there already, so I'll just close that. Release notes. Google have been doing a good job of regular upgrades here, so it just tells you all the Python packages have updated. So they give you standard Python, but they also throw in a few third-party libraries, and these are the third-party libraries that they've recently updated, but there's a whole stack of other ones that are in there as well. I'm just going to close this tab for the release notes because we don't need that. Now you can click on connect up here in the top right. If you don't click on it, it'll just be a bit slower when you start to do stuff. Okay, so what is a notebook? You can see it ends in .ipynb, which is an interactive Python notebook, and it's just a mixture of cells. This cell has got a blue border around it, and that's just some formatted text where I've just written what we're doing here today. I'll put a few links like to this actual notebook, to the YouTube video so you can go back and look at it again later, to the meetup event, and also we've got a copy of my past live sessions, the online sessions, in this GitHub site, so you can go there and have a look. This one's not there yet, but I'll get it up there in the next few weeks. And but you can look at all the past ones, and if you've got any ones that you're interested in, you can go and look at them, and they'll give you a link either to a Colab notebook itself or to some code in a GitHub repository, and a link to the video so you can watch and see what's going on. All right, if you want to run Python on your computer, you could use Colab, or you can install, say, Python. Latest version is 3.14.3 from this place. That's their website, python.org. Alternatively, you can install Anaconda, and I shouldn't have double-clicked. Let's go back here. Anaconda. It's another way of installing Python, and it includes a lot of third-party libraries. This one from python.org doesn't give you the third-party libraries, but these days it's actually quite easy to install the third-party libraries, so some of the benefits of Anaconda are not there anymore. I don't ever use Anaconda myself. some data scientists really do like it. Another thing you can do if you're installing onto your own computer is install an integrated development environment. And there's a couple there. I really like PyCharm, the community edition from JetBrains. A lot of people these days are using Visual Studio Code, and it's quite good. It's got some lots of extensions, and it links quite well to AI prompting. Even PyCharm Community Edition is also, you can put in agents to help you code as you're coding. All right, I'll go down to the next cell here. I'll just click on it. You see it's got the blue border around it. There are different ways to write Python. So Google Colab uses what's called a Jupyter Notebook, and Jupyter Notebooks are an extension of IPython, which stands for Interactive Python. You could also do all these exercises just in straight Python if you downloaded it from python.org. Yeah, so the advantage of the interactive Python, it just gives you a little bit more for this sort of work, because you can run a line of code and see what it does, but it's really like you're still in the program, because it still remembers all the variables and what their values are, and then you can just type in the next line if you want. So this notebook, we've just been looking at some text cells, and there's another text cell, and then down here in with the grey borders, which, and I select that, this is now a code cell, and at any time I could put in a new code cell or a new text cell just by hovering between two cells, and it lets me insert either of those. Now the code cells are where you can put in Python code. Now the first thing I'm going to show you is just how to get help. So these are comments, because they start with a hash symbol at the beginning, and that means that Python will just ignore them. And I've commented out this question mark because sometimes people just go up to here and they say run all the cells, and if it comes to a help thing, then that can slow it down a bit. So let's uncomment it, run the question mark. It probably would run actually. It just opens up a new tab over here on the right, and gives us some help about how to use interactive Python. So that's always useful. But anyway, well, I do have a session purely on using Colab. If you want to go back and look at that, it'll go through some of those things in more detail. Let's get on to coding. Coding is all about writing commands for a computer to follow. The commands that a computer can do are rather quite simple, but it can do them very, very quickly, and it can do lots of them. So one command would be to use the print function to display something. So we could display what 5 plus 3 is using the print function. And so this is standard Python. We've got the print function, word print, open the parentheses, put in what we want to print, and close parentheses. It evaluates it and displays it out here to the display. So print means show it on the display. In the early days, when people were using computers, they didn't have a screen. Everything they typed would go to a printer, and that's where the print command, often why it says print. They had like a teletype printer. Every line you typed, it would come out on paper, so you didn't have a screen. So this is standard Python. Now in the next cell, I've got a variation of that, which will only work in interactive Python, and that means you just leave out the print. If you put an expression on the last line, it will display that result without even requiring the print function. So you can see it's evaluated 4 plus 5 and displayed the value 9. Now if I've got several commands, they're executed sequentially, like one after the other. So in this cell I've got 2 commands, print 4 and print 3, and I run them, and it runs them both, and you can see now there's 2 lines of output. Unfortunately in interactive Python it only displays the last line, so if you do want to display more than one line, even in interactive Python, you will need to use the print functions. So let's run this. You can see I'm running the cells just by clicking on this play button in the left corner, or I could actually type Control Enter on a Windows computer to run it. So you can see if I run that cell, it's only displays the last item, which is 1. We're just going to be introducing a few simple concepts of Python first before we get into functions. One of them is variables. So variables like a memory location where we can store some data. So we're going to create a memory location. We're going to call it X, and we're going to store the number 3 in it. And then we're going to use the value of that memory location in another formula, and that formula is going to be x times x minus 4 times x plus 4, and we're going to calculate all that. So every time it says x, it's going to look at the memory location called x and pull out the value that's in there, substitute it into this formula, calculate it all out, and then store the result in a new memory location, and we're asking to call that new memory location y. Then we're going to print out the results. Now I'm going to use f strings for that. So an f string, it's a little bit advanced, but if you can understand it for now, it'll then just save a lot of typing later on. So anything in the quotes is a string. Anything inside, if we put an f out the front of the quotes, then it becomes an f string, and that means we can use curly braces inside the string to evaluate expressions. And the expressions I want to evaluate are what's the value of x and what's the value of y. So it will display that as x equals 3, y equals 1. So it's substituted 3 into this. 3 times 3 is 9, minus 4 times 3, so 4 times 3 is 12. 9 minus 12 is minus 3, and then add 4 and we get plus 1. And so it stores the value plus 1 into y. So a typical thing that you might want to do in your program is calculate y for lots of different values of x and put those into lists. We're not going to talk a lot about lists, but we can use square brackets in Python to say I want a list, and then we can add, we can append data into that list and build up these two. So I've called them list x and list y. And so if we run this, we see I've gone around this loop 41 times, each time with a different value of x, and built up the lists, and just the first 10 of them I've printed out what x equals and y equals, so you can see what's going on. I didn't do it for 41 times, but I did show you what the full result is. These are all the values that have been put into the x list, and these are all the values that have been put into the y list. And we'll look at those values a bit more closely later on. But let's see what we can do with those two lists of numbers. We can import we can use a third-party library. So normally on your computer we'd need to install this, but fortunately Google Colab's already installed this one for us called Plotly, and we can plot it. So to use it in our code, all we have to do is import it, and then we can run px.line to draw a line graph of our x and y values. So we've got 41x values going from 0 up to 4, and we've calculated y for each of those, and it gives us this nice parabola that we've now plotted. Okay, so now we're going to talk about why would we use functions. Now it becomes cumbersome and error prone to type x times x minus 4 times x plus 4 every time we want to calculate y. We actually only typed it once before because we had it in a loop, but if you're trying to do that from different places in your program, then you'd be having to type it out, and if you get it wrong in one spot, it's going to be hard to notice that, so that's where errors can creep in. So a solution to this is to define a function that calculates that result, and then we just call the function whenever we need it, and we know it's always going to be the same function because we've only defined it in one spot. So when we define a function, we use the def keyword, and that says I'm defining a function. We give the function a name, so we can call it f, but we could call it, you're pretty free to call it whatever you want. You can't call it a keyword, but anything else is fair game. And then we say how many arguments are we going to use in our function. So remember we had those x's in our function. So let's call our argument a, and we put in the function in terms of a squared minus 4a plus 4. And now we've defined a function. Now if we want to call that function and get the result, so if I've got to run this first, so I'll run it. Now it's defined the function, and now to call the function, I just do the function name, open parentheses, and put in the number. And so if we put 5 into there, then we get 9 as the answer. And we've got Anurag Kumar has said hello. So g'day, I'm glad you're watching. So task 1. Now I'd like to set some challenges for you, and I've left a spot here, a blank cell that you can type in the answer and try to do it. So you either pause the video, or I'll now go through the answer. Task 1, call the function using an argument of 2.5. So you can see we've called it with an argument of 5. So to call it with an argument of 2.5, we say f of 2.5, and then we run that command by pressing the play or control enter or shift enter, and it comes back with an answer of 0.25. So that calls the function and displays the result. If now I've put a solution here for you, slightly different solution, different way of doing it. So we're going to call the function, we're going to store the number in a, we're going to store the argument in a variable first, and then we're going to store the result in another variable, and then we're going to display the results using the print function rather than just interactive Python displaying the results. So let's see what that looks like. And we get solution 1, f of 2.5 equals 0.25. So it gives us the same answer, but it's also used these variables along the way. Now Python's dynamically typed. You might have been used to other languages like Java, where you have to, it's quite strictly typed, so you have to say what type every variable is going to be. But in Python, we can use the variable could be a lot of types, and this our function will actually work. Where do we define the function? We define it up here, and you can see the only way things we've used to define it is the multiplication operator, which is an asterisk, the subtraction operator, which is a minus sign, and the addition operator, that's a plus. So we could pass through anything that understands those operators, any data type, and it would work in that function. To look at what a function is, we can use the type function. That's a built-in function for Python, and it will tell us what type things are. So our first example is going to be looking at 3. Our second example is going to be looking at 3 dot. So think first, before you run this, what you think is going to happen. And now I'm going to run it. And it says x equals 3. It tells me the type of x is an integer. It's going to calculate what y is. And then it's going to tell me the type of y. And so y is also an integer. So we pass an integer into our function, we get an integer out. And the result is f of 3 equals 1. Now if we do 3 dot, that's actually a floating point number. So it's stored differently in Python. It's got some different characteristics. You can have fractional parts to the number. It doesn't have to be whole numbers like an integer does. So when we say what is the type of x, Python tells us it's a float. We say what is the type of y when you run it through the function. After you've run it the result of the function, and the result of the function is now a float, even though it's the same variable. Actually, we're using the same variable name for these as we did up here. And then we display what the function's doing. It's taking 3.0 as the floating point argument and returning 1.0 as the floating point result of the function. Okay, so when you're writing code and you notice that you're doing something like repeating the same lines over and over again, that's a good time to think maybe a function is something I should be doing here, so that I don't make mistakes in some other one time when I type it over and over again. And you see here I've got pretty much the same code repeated twice. So let's, where I store the value, I call the function, store the result, and then I check what the type of x is, what the type of y is, and I display the operations of the function. So we can stick all of that into another function. In fact, one of the beauties of Python, this is a little bit advanced, so don't worry if you don't understand it for now, because it's not something you'd do a lot of in your early days, but you can pass a function as an argument to another function. So we're going to define this function, print the function result. The arguments, we're going to call them fun and x, and fun is actually going to be a function, and x is going to be a value which could be of any data type. And once function comes in, we can then call that function just by saying fun of x, and then we can check the type, so what x is, what y is, and look at the result from the calling the function. So if I define that function, and then I say x equals 3, print the function result, and then x equals 3 dot, print the function result, I get the same output as I did before. But now I can do it with other things as well. So I've left it as a task for you. So if you could have a go at that, and you can start having a go at that, and while you're doing that, I'm going to answer this question here. What is the name :7s? That's a very good question. Yes, so this, I've used it up here when I've said what's the type of x. So let's have a look. If I say what's the type of 3, it returns integer. But if I say print the type of 3, I get this thing here, class int. And that's not what I want. I just wanted int to come out. So what I'm doing is I'm looking at, this is an object, and I'm looking at an attribute of that object, and the attribute I'm looking at is called _name . So the way I get that is, and you can see in Google Colab, it does some command completion. It tells me all the other attributes or that I could have called on this, and some of them could be functions and some of them could be values. And we can select the one name _. So these double underscores, when you're talking to Python people, they'll often refer to that as dunder, just for short. So type 3 dot dunder name is what this is, and so it's got a double underscore at the beginning and at the end. And when I do that, I get the int, which is what I really wanted when I was displaying it. Now, looking back at the f string, you can see I've also got this colon in here and a 7s. So when you're doing f strings, whenever you have a colon, it means everything that comes after the colon is your format. So you define the format. I've defined the format that I want it to be 7 characters wide, so I put a 7, and I said the data type of what I'm expecting is going to be a string, so I put an S for that. So that's just one of the formats that you can use. I've done a whole sessions on F strings, and the formatting is really powerful that you can do with that. So I'd suggest looking at my F string video if you want to see some other formats that you can use. And so by doing that, I got it to look nicely here. You can see I've printed int here and float here, but I wanted these next colons to be lined up. So I made sure that these were 7 characters wide. So that's 7 characters wide. That's also 7 characters wide. And then everything else stayed lined up with this, even though it was 7 characters. Even though they were varying characters, they're now all 7 characters wide. Now I didn't put a format up here, and I won't do a format at this stage because at this stage we don't know what data type is going to come through. Okay, getting back to the task, let's see how people have done with that. So we're going to try to create a decimal. Now we have to, it's a standard library, so you don't need to install anything. Like the third-party libraries need to be installed, but you still need to import it to use it. So I need to run this cell. I can tell the cell hasn't been run yet because in between these square brackets there's no number. If I click on the play button, it now says that was the 20th thing that I've run here, and I've imported decimal. So now I can print the function result of f using decimal.decimal 1.1. That looks good. And I told you that's what it was going to be, that you need to send to it. And we're going to run that. So it says the type of my x going in is of type decimal. The type of y that it calculated is also of type decimal. So it's worked out because decimal knows what to do with pluses and minuses and asterisks. It returns a value which is also a decimal, and I can print it out, and I say the value f of 1.1 equals 0.81. Now you remember, I'll just insert a new code cell up here and said what's f of 1.1 when I used a floating point number rather than a decimal number, and it came to 0.80999996, and that's a quirk of floating point numbers, is they're stored in binary, but it's very difficult for a lot of decimal numbers to store them exactly in binary, so they'll have some sort of error. So sometimes it will be fine. So if I do f of 1.5, that'll be fine. It comes out as 0.25. But some numbers, the error accumulates and it finally gets so big that Python will display it in one of those what looks to be inexact. So if you're doing something to do with accounting, often you want it to be exact, so you would use this class decimal. If you're doing scientific stuff, it doesn't really matter, because in science 0.80999996 is effectively equivalent to 0.81 anyway. It's not going to change the result because we're not dealing with exact numbers anyway in science. But accounting we are, so you might want to use floating point numbers, floats, if you're using scientific calculations, and use decimal if you're doing accounting type applications. Alright, so here's the solution. It's pretty similar to what I did. Oh, okay, so the difference, I've just done a different way of importing. So remember before we did import decimal, and then I had to define my decimal using decimal being the library that I've imported, dot decimal with a capital D being the class inside that library or that module that I wanted to create a new instance of, and then the value that I wanted to use. But if I just import the class decimal from the module, the library decimal, then I can now refer to it with the simpler notation of just capital D decimal and the number, rather than having to put the library name out in front. So that makes it a bit easier. And you'll notice that when you're passing in these numbers, you should do them as strings. And the reason you're doing that is because if you leave the quotation marks off, Python will convert it straight to a float to start with, and once it's a float, you've already lost some of your accuracy because it can't store a floating point number exactly in binary, and so it's too late. The decimal will never regain that accuracy. So sending it through as a string means it doesn't do any of that pre-processing. It works it out straight from the string that you send it. Let's run that, and there's the example that I gave. If we use decimal, we get an exact representation, and if we use a float, we get the floating point errors that are quite common in a lot of programming languages to do with converting decimal numbers to binary. Okay, task 3, rewrite our loop from before, which created list X and list Y, but this time calling the function. Alright, so have a go at that. I'm going to do it as well, so you can pause the video if you want to do it without seeing the answer. So we had a loop back here. So I'll copy and paste that. Task 3, here we are. So I'll paste it in. Here's our loop. We've got an empty list, an X, a list, Y, and then rather than Y equals this, we'll call our function. And we call our function F, and we'll pass in the argument X. And we can run that. And that worked. And so that's really saved us the issue of maybe typing the function in slightly wrongly. Later on, maybe we change the function, but we don't change it in every spot that it's used in our program, and then we've got some parts of our program are using the old function and some are using the new, and so that's where the danger can happen. There's a programming motto or mantra that says dry, don't repeat yourself, DRY. So if you're ever typing the same code over and over again, then maybe there's a better way of doing it, and putting it in a function is a really good way of doing it. All right, I don't quite understand the function within a function. Can you please explain again? Yes, and don't worry if you're having trouble with that, because it is a complicated concept, but I will have a go at explaining it again. So say we've got a couple of functions. So there's one function is minimum, and so if it looks at a few numbers, it'll find the minimum value of those. All right, and then there's another function called max, which we could do the same numbers, max 6. Okay, so it's found the maximum value of those numbers, minimum's found the minimum value of those numbers. All right, so say we know what the numbers are going to be, but in our code we don't know really what the what function we want to call. Maybe we've got a couple of buttons on our application, and the user can press a button that says tell me the minimum, and the other button is tell me the maximum. All right, so we'll have our list is our numbers 256. So that's the data that we want to use, and so I'll just run that. So we've stored it in a variable, and now we've got a we want to have a placeholder, which is going to be the function that we want to use. So let's call it my function. All right, now I could define that function, or I can just assign it to an existing function. So if I say I want my function to equal min, like that, and run that, then when I call my function of list, it'll tell me the minimum value. Now I could also go back up here and say I want my function to be max, and run it and say my function, I call it on list, and it's 6. So you can see I've just said this function name, which I haven't even had to define because I'm just using a predefined function. I can just assign it to either min or max or some other function that I want to use. So I could actually pass that through as an argument to another function. So if I create a function, we'll call it process, and process my list, and all I need to do is say which one I want to do. Do I want to use the min or do I want to use the max? So I create an argument, my function argument, let's like something like that, put a colon in there, and then I can return my function argument of list. AI's worked it out all for me because that's what I was going to do. And so now I'm passing through to this function which function I want to substitute into that spot there. So I can say process my list using the max function, and it tells me 6. Or I could do the same thing with the min function, and it will give me 2. There's probably a function average. Let's have a look. I think there is. Unknown. Maybe it's called mean. No. Maybe it's statistics. All right, so I've imported this mean function from the statistic package, and now I can do the same. I can pass it into process my list, which takes the mean function and it applies it to my list of data. Now normally when you're running functions, you would have the data is what you pass through as the arguments, and the function is what's built into your function. But there's going to be times when it's the other way around, and Python can do that for you. Wow, that's cool. All right, sounds like you understand what's going on there. It's a different concept, but yeah, that's good that you can understand it. All right, so we're just doing solution 3, task 3, rewrite our loop. So we did the loop and we just used the function there. Now let's have a look at the solution that was provided. So this solution is using a feature of Python. It's more to do with it's a thing called list comprehension. That loop that I did is such a frequent thing that you will do in Python that they've created this syntax to do it in a lot fewer lines. So you could say, I want a list of x to be I divided by 10 for I in range 41. And then list of y equals, I want it to be f of I over 10 for I in range 41. So this code here is equivalent to all those lines of code that we copied and pasted before. And you'll see that it gives us the same answer. So if you start seeing these for loops inside, say, square brackets or parentheses, then that's doing list comprehension or tuple comprehension to create a list of data. And I'm just showing you that as something different. I'm just taking advantage of that example to introduce an alternative way of solving that problem. But let me know if you want me to go in more detail over that list comprehension. Okay, moving on to the next bit. So Python has built-in functions, and they're just like the functions that we create. They are called by, you type in the name of the function and then these parentheses. After the name of the function means you want to call the function. If you don't put the parentheses there, then it means you're using the function like a value, like an object, which is what we did up here, where we said my function equals max. You see, we didn't have any parentheses there, so then we're just using max as an object, and the object being a function that we're assigning to another variable. But once you put the parentheses after the function name, could be either max or my function, and pass in arguments, which there may be known arguments, then it will actually call it like a function and run it rather than have a value of it as an object. And so print, here's an example, print with no arguments, just prints an empty line. I did that, okay. Print with one argument, which is a string, will print hello. I don't know what these three dots do. Oh, copy cell output. I was wondering what they do. Okay. Okay, so task 4, what other built-in functions have we already used? Now I probably shouldn't scroll up and down all the time because people will lose track of where I am. But if you want to scroll back and look at different places where we've used functions and see if you can spot any. Now I'll just go through a few that I've written down here. One was the range function, so it's a built-in function in Python, and it's a stop value when you want to iterate over a bunch of numbers. So if we did a loop 41 times, so we just said for I in range 41, and I would have every value from 0 up to, but not including the stop value, which was 41. But the number in the stop will actually be the number of times you're going through the loop. We also use the built-in function type to find the current type of a value. We also used px.line as a function for drawing a graph. It had 2 named arguments. So see these ones, we just put an argument there, and they're called positional arguments because we didn't give it a name. So it just works out position, it's in the first position, it's in the second position, to know which argument it's being used. But you can actually name the arguments when you're calling them, and we did that when we called px.line. We said we want x to equal list x and y to equal list y. And the advantage of using named arguments is you can rearrange the order. It doesn't matter what the order is, but you just have to name them. So if you want to do any positional arguments, you can mix and match. You can have positional arguments and named arguments, but you have to do all the positional ones first and then the named ones second. Okay, then we did this one. So it looks a bit like a function. It had a name, decimal, and then it had parentheses and then a value, which was the string. But it's not really a function, it's a class. Decimal is a class, and so decimal parentheses is what's called a constructor, so it will create an object of that class. So one of the conventions that Python uses to try to make it a little bit clearer, are we calling a constructor or are we calling a function, is the convention is that when you're calling classes, you name them with uppercase characters, so title case. So here's an example of title case. So every word in the class name has a capital letter to start with, but no underscores in the class name. Now when we're doing function names, we do them all as lowercase, but we put underscores between each word so we know where the word breaks are. So that's a convention. It's not used all the time, so but most of the time it'll be true, and if you can follow that in your code, then you can it'll make it a lot easier for other people reading what's going on. So let's go on. Functions don't need to have arguments, and let's have a look at the date time, some functions in date time. Now after I've told you all about this convention, the first thing I'm going to do is give you an example of one that doesn't follow the convention, and that's this datetime class inside the datetime library, and it doesn't have capital letters, and it's just all one word. So you just need to know that that one's a class, it's not a function. But we can call functions within that class, like we can call the now function, and that will return the current date time. So to call it, we import datetime, and then we've got the class inside that is datetime.datetime, and then the function is datetime.datetime.now. So that's what we're going to call after we've imported it. Then we're going to format that as a time, and we're going to pull out the year, the month, the day, the hour, the minute, the second, and the microsecond. So, and we're going to put this into a function called showtime, and every time we call showtime, it will display it. And there it is. So I've run it, we've called showtime, and it's displayed it. So just to prove it, I'll create a new code cell here, and you can create new code cells as we're going along as well. Run showtime, it does the same thing again, and this time you can see it's a few seconds later. So 1st of April 2026, 8:16 and 59 seconds and 609,584 microseconds, and that would all be in, it looks like GMT. So Google must run their servers on GMT, which is a wise thing to do. So the point of that was functions not needing arguments, and the now being an example of that function, and just some things we can do with that now. Oh, and then we defined our own function, which also didn't need an argument, which displayed it all broken down. So our functions so far have done things. They've printed results out to the display, but functions can also return values, and you do that using the keyword return. So for example, we're going to define a function here that's going to find all the available time zones and find out what regions they're in, and then just return the regions. So like Australia is a region, and it has several time zones in it. So we don't want every time zone in Australia, we just want to know what the regions are. And the way we're going to do that, we're going to create a set. So a set is a different sort of collection. You can have lists as a collection that we've done before, sets another one, and sets, the feature of sets is that they don't have duplicates. So if we put a value into a set that's already in there, it doesn't create two of that value, it just leaves it the one. So this is going to be a quick way of eliminating all the duplicates. We just keep adding regions to our set, and then it will, if the region's already there, it'll ignore it, and if the region's not there, it'll add it into the set. Now we're going to look at, we're going to use the zone info library to give us all the available time zones. And sometimes the time zones, they'll have a region followed by a slash followed by a area in that region. So for example, Australia / Queensland. But sometimes they'll also, the region itself only has one time zone, so they won't have any slashes in them. So New Zealand, for example, NZ will only have one time zone. So the time zone is the region and there'll be no slash. So what we're going to do, we're going to go through all the available time zones. We're going to look for a slash in the name of the time zone. If it's there, then we're going to split on that slash and just take what's before it. Otherwise, we're going to take the full time zone and add it into our sorted regions, and that's our function. So we'll define the function, then we'll call the function and store the result into list regions, and you can see here that return command is what's going to return the results to us. So here we go, Africa, America, Antarctica, Australia, and they're all the regions that have got time zones. So that was pretty fun. So task 5, define a function which takes one argument, the region, and returns the time zones in that region. Okay. So I'm going to base it on this function here. And let's paste. So I'm going to call it regions for time zone. Actually, I'm going to say time zones for region is what I'm after. Time zones for region. And I'm going to pass in the region that I'm going to check. So let's create a set called time zones. That'll do. And we're going to go through all the available time zones. If it's got a slash in it, then we're going to find the index of that slash, and then this is where we change the code a bit. We're going to say if region equals the time zone of that, then colon and new code block time zones dot add and the time zone itself. Otherwise, if region equals time zone, then add it. So this is the first case is where there's more than one time zone in a region, and the second is for the case where there's only one time zone in a region. I guess we can sort them. Sorted time zones equals sorted time zones, and we return the sorted time zones. All right, so that defines the function. I just ran it, so it's now defined. Let's try running it. Let's try calling that function. So time zones for region Australia, and there are all the time zones in Australia, quite a few of them. Okay, let's have a look at New Zealand, and there's only one. So our function works. Okay, so we've here's a solution here, which will do it in a slightly different way. And what it's doing is it's looking at the two functions that we've created so far and gone, actually, there's a fair bit of duplicated code in there. And remember, don't repeat yourself. We shouldn't have duplicated code. So we want to have a function that extracts the region for a particular time zone. So all this stuff about checking for a slash and then just getting the what's before the slash or returning the whole value, we'll put that in one function called region for time zone. Then we'll have our time zones for region. We can just use list comprehension and say time zone for time zone in all the available time zones if the region equals region. And our time zone regions, which was the original function we created before, can also use the region for time zone, and it's using a sorted set to ensure there are no duplicates there. Okay, now I've put in the comment here, using our new function region for time zone is more reliable than New Zealand chat starts with New Zealand, because as you can see, New Zealand chat is not in that region, but it does start with NZ, so it could give a false result. So there's an advantage, and here we'll try running it for time zones for region Australia, New Zealand, ETC and UCT. We can also find all the time zone regions just to check that that's still working, and well, let's run that for now, and then we'll see what that help function does. Okay, so the first one, there's the time zones in Australia, that's good. Time zones in New Zealand, that's good. In ETC, so they're useful to know. Time zones for region UCT, so that's Universal Coordinated Time. And then we've got all the regions, so that looks like the same list as before, so that's good. Now what's this help region for time zone? So we've just created this function region for time zone, but we can call help on it, and this is what it returns. It tells us the name of the function, what arguments it needs, what the function does, and how to use the function and something else about it. And where's it got that information from? And it's got it from here, is we've created what's called a doc string. So the doc string is just a string, and it's a multi-line string, so we've enclosed it in triple double quotes and put it just after the definition. And Python looks at that and goes, well, that must be some documentation that you've created for that function. And so now people can call help on your function, and they've never seen your function before, but the help should give them enough information that they should be able to use it now. So the help's going to use what's in this triple double quoted string. It's not going to include this comment, because that's a comment rather than a string, and that's just a hash, and so the comments are just totally ignored. All right, so whenever you write a function, it's a good idea to create a doc string so that you know what the function's trying to do. And when you come back many years later and go, what was I thinking? How do I use this function? And so if you've written a good help for it, then you'll be right and be able to use it. Just a word of warning when you're using the ETC time zones, they're a bit weird. So see, we'll look at Australian, so Brisbane time is 10 hours ahead of Greenwich Mean Time, and you see the current time in Brisbane is 18:28 on the 1st of April. Now if we were to set this time zone, GMT plus 10, that actually means 10 hours behind GMT. It means that I think it means to get to GMT we have to add 10 hours, and so it gets that time. So if you're wanting to write the Brisbane time zone using the ETC notation, you have to use GMT minus 10, and you can see that gives you the same time as Brisbane. But yeah, just be careful with that one. It's sometimes a bit counterintuitive. Help can work on built-in functions. There's the print help. So yeah, any of the built-in functions in Python, run them through the help command, the help function, and it will give you some idea of how to use it. And when you're in IPython, you can even do like a question mark help, question mark print, and it does the help for print up here over on the right. Arguments to a function can have default values, like this we saw with print. It's got a separator, it's got an end, and it's got file and flush. So separator, if you print many things, by default it'll just put a space between them. But if you want something else between them, you can say what you want to separate the values with. And by default, it'll do a new line at the end of the line. But you can say what else you'd prefer if you want to override that value. And you can see, so these are all your arguments that you've sent, all the positional arguments, followed by these named arguments: separator equals, end equals, file equals, flush equals. File, that's a file-like object where you want it to go out to, and it defaults to sys.standout, which is standard out, which is what we want, which is to display it to the screen. Flush, whether to forcibly flush the screen, the stream, and that by flushing it, it means it's not going to wait any further for any other print commands or functions, print functions, and so it's going to send it all at that point, but it defaults to false. Okay, so that's all good. You'll normally write functions with named arguments. That's what I do. So if we write a function total seconds, minutes equals, and seconds, and then you can put default values in there as well. So if they don't specify the value, then it'll use the default one. So let's have a look at this one, total seconds. So we've got 32 minutes and 15 seconds. That's the same as 1,935 seconds. So we could have called it this way with just the arguments in what order they're in, or we can, if we want to use a different order, we can name them. So we could say seconds equals 15 and minutes equals 32, and then we can put them in a different order. You can also use some ordered and some named, but the ordered ones have to come first. So with just two, it doesn't really make any difference. Okay, expand total seconds to take three arguments: hours, minutes, and seconds. I think that's pretty straightforward. So I'm just going to go straight to the solution here. And we can run through our examples, having a look at the differences between the ordered arguments, the named arguments, the ordered and named arguments, or what's that one? That's calling by name in a different order. Oh, so this one's calling by name and leaving some arguments to just use their defaults, and this is providing values for all of the arguments. So let's run them, see what it looks like, and that all looks good. Of course, we expect a different value for the last one because it's now got 1 hour in there. Okay, another task for you. Define a function which converts a temperature in Celsius to Fahrenheit. And so C is going to be the value in Celsius, and we're going to use this formula to tell you the Fahrenheit equivalent. That's pretty simple, so let's just go straight to the answer. I'm not going to do anything different to that. We'll call our function Fahrenheit. Our argument will be called Celsius, and Celsius times 1.8 plus 3.2. That's plus 32. We run that, and then we can call it 0 degrees Celsius is 32 degrees Fahrenheit, so that's freezing point. Boiling point, 100 degrees Celsius is 212 degrees Fahrenheit. And I always like minus 40 because it just has the same number in both Celsius and Fahrenheit. All right, so that was just an example. Now, some things that we can do. This is a bit more advanced, and for beginners, I wouldn't say do this stuff, but I'm showing it to you now, so if you're reading other people's code and they've done it, then you understand what's going on. And it's all about packing and unpacking parameters. So say we had the parameters in a tuple, which is like a list, and you could have done list here as well. That would also have worked. So we've got 1, 2, and 3, and we want to pass that as arguments to the function total seconds. Now we could have done it this way: params 0, params 1, params 2. So tuples work just like lists. So we can refer to the first one as 0, index 1, and index 2. We do that, and we would get the result 3, 7, 2, 3. However, there's a shortcut in Python which basically unpacks all the parameters into their positional arguments. So if you just put an asterisk in front of the name params, it'll unpack them, and it'll be as though you've called total seconds with those parameters in order 1, 2, 3, and it gives you the same answer. Yes, that's, tuples are immutable, right, and that's a really important point, and for that reason I would actually recommend that you use tuples wherever you can, and only use lists when you actually need the mutability of the list. So you got a question mark here, star tuples. Yeah, so you can put the star out in front of anything that can be unpacked. So it could be a list, it could be I think you could do a set. Maybe not a set, because a set, the order is important. So lists and tuples, they maintain the order of the values in their collection. So putting the asterisk out in front of them means it will just unpack that list or tuple and put the parameters all in order and pass them through as ordered arguments. Now another thing we can do is using dictionaries. So this is a dictionary, and you remember dictionaries can have keys and values. So we're going to have strings for keys and values for integers, are going to be integers. So we can say we want the seconds to be 1, the minutes to be 2, and the hours to be 3. Now we could pass this to the function by saying seconds equals params seconds, hours equals params hours, and minutes equals params minutes. But there's a way of unpacking a dictionary as well, which is this double star. So if you unpack a dictionary with double star, it'll use those names and those values to pass to the argument. And you can see how we've got them in a different order. We've put seconds, minutes, and hours, even though in total seconds the function is expecting hours, then minutes, then seconds. So if we run it, well, first of all we create our dictionary and that one way of calling it, and now we use it unpacking the dictionary with this double asterisk, and we get the same answer, 10921. All right, so now the last thing I'm going to show you, once again mostly so that you can understand what's going on if you read it in code, is it's the other way around. How do you pack a whole bunch of arguments into a single tuple, or how do you pack a whole bunch of keyword arguments, named arguments with values into a dictionary? And the way is when you define your function, you say I want all the positional arguments to be put into a variable, and I'm going to call it arg, and all the named arguments I'm going to put into a dictionary, and I'm going to call it kwargs. And these are actually quite conventional names that people will use, so but they don't have to be that. You can call it whatever you like. And then once they're there, and this is how you cope with a function that you want to have a variable number of parameters sent through. So an example of that is the print function, because with print you want to be able to print a whole bunch of values, but you don't know ahead of time how many values there are going to be, and you don't want to limit it to a specific number of values. And so, say you guess 10, someone's always going to come along and want to do 11. So by doing it this way, there's no limit to the number of arguments that they can provide to the print function, and or in our function, which we're calling unexplode, there's no limit. We're going to collect all the unnamed arguments into args and all the named arguments into kwargs. So let's run that just to see the example. It's found those 3 positional arguments, 5, 6 and 2, and then we've got these 2 named arguments here. And so for the first named argument, the name was 4th and the value was 10, and the second one, the name was 5th in lowercase and the value was a string, was 5th all in uppercase. So I hope that's you've learned something from that. Functions can be a lot of fun, and they're very powerful, and they can certainly stop you repeating code, and then and you can pass them around just like objects. So they're very useful in that way. And yeah, that's your Python is just made up of lots of functions, all your Python code. So it's a very important concept to know. So if there's no more questions, thank you for watching. Hope you liked it. You can like the video and subscribe. Okay, try to add on LinkedIn. All right, I'll keep an eye out for you. And that's good. Thank you very much.